At Epicmax, we focus on building projects using Vue.js, and we've even developed our own Vue-based framework called Vuestic UI. Today, as you can tell, we are passionate about Vue.js, of course, and these meetups are designed for same enthusiasts for all experience levels, whenever you are a seasoned developer or just starting out. So today, we're gonna listen 3 topics. First one is about Vuestic Compiler. Second one about Rethinking SOLID Principles in JavaScript. And the third one, it's about understanding and solving hydration errors in Vue.js, in SSR, of course. So don't be shy, turn on your cameras. As I said that before, be polite. You can ask your questions at the end of every session, every speech. So put your questions to the chat. We'll pick some of them and ask our speakers. So thank you all for joining. Thank you for participating. And I'll pass microphone to our first speaker, Maxim. Maxim is our lead developer in Vuestic. He'll be diving us to Vuestic Compiler. He's also go-to person for anything related to the framework. So don't hesitate to ask him any questions about that.
Yeah,
Maxim.
thank you for doing all of this.
Sure. You're welcome.
Thank you, Pavel. Can you hear me well, guys? And let me know if you can see my screen.
Yep, all good.
Thank you. So let's start my presentation with a quick review of what Vuestic UI current state is. So as right now, we provide over 50 customizable components, and you can customize each of them with CSS variables. You can globally set up colors, icons, breakpoints, etc. We have a good preset system. In presets, you can store component props, classes, styles, slot text, and or components for the slot. In addition, we cover extra stuff like validations, mask, and integrations with other cool projects like Tailwind, plugin auto import, Next. So we made these features to save your time, to make your development process easier. But of course, the cost of using any large framework is impacting your bundle size and runtime performance. And unfortunately, as a developer, you need to learn how to work with these features. So this is why we made Vuestic Compiler, which will give us framework developers more freedom and control over your developer experience. So how it works? Basically, we move some of the Vuestic features to build time from runtime, saving your bundle size and removing extra runtime overhead. Let's look on this simple example to understand what I'm talking about. Imagine that we have a date input component. Date input itself can be separated by features. Like we have input field, which has its own styles, icons, hover effects, everything like that. We have a drop down with calendar inside, calendar itself, and we have a date mask feature. And we also have a lot of other features that we can omit for this example. So you see on this slide, we're using mask, and you can say it pretty obviously because we have a prop mask and we're passing the mask to the component. But what if we are not using masks at all for this component? So compiler can detect that mask feature is not used, we can completely remove this from output bundle. And we plan to implement this build time optimization for the most components to make your applications more lightweight. And the coolest part about this is you don't need to do anything with your code, and it will just work under the hood. Another feature that compiler can provide us is for front-end monsters who like to build their applications from the ground. We can introduce the clean theme, which only includes important positioning styles. And you can, instead of overriding our pretty theme, you can write the styles from the ground up. And it will not only reduce your bundle size, but remove this struggling from overriding existing classes. Let's talk a bit more about developer experience, because previous talk was more about performance. So for developer experience, firstly, we want to replace the CLIs and boring config setups. Right now, to integrate Vuestic with third-party solutions like Tailwind or Luna CSS, you need to spend time on reading docs and configuring your development environment. We can move this process completely through Vuestic Compiler. We plan the compiler to check if you have, for example, Tailwind installed in your project, and compiler will configure Vuestic and Tailwind to work together during dev and the build process. So what steps will be required from you as a developer? You will need to install Vuestic, install Tailwind, and go and make your own application, because everything will be configured under the hood. This is how we slowly taking control over your computer. About taking control over your computer, compiler also allows us to generate types for icons, for colors, for interization strings, and other suggestions like presets. We can generate these types, which will be used by your IDE to give you suggestions. So you don't need to remember what actually you have in your Vuestic config. IDE is cool enough, but we have something more interesting. We're introducing new DevTools built in browser, built in your application. And with DevTools, you can build your application. So basically, the DevTools is an interactive way to build front-end. It's actually a tool to modify your code visually. So you're still working with your local code, with your local branches, but you can do this visually. Now you can change component props, you can edit slot text, you can configure layout settings, and you can remove and add new components. And of course, all of this will be in sync with your configuration in Vuestic config. We also plan to add presets editor into DevTools, so you can build a new presets from Vuestic components and quickly reuse them across your application. Maybe we also will add a backend integration into DevTools, so you don't need to write backend as well. But for now, we're only focusing on simplifying your front-end work. We can simplify it even further. So we're also working on the AI solution. Later in the future, you can forget about reading documentation, reading about prop names, prop types, and you can just ask AI to do some kind of boring stuff. Just make this button red and add an icon, and it will add the icons and colors. That's it. A bit quickly, but right now you can play with Vuestic and Vuestic Compiler. Compiler is still in development process, but you can use right now DevTools. So we will appreciate any feedback, any feature requests, and any other contributions. You can read more at vuestic.dev, or you can join our Discord server in case you have any questions. I would like to discuss them together here. And yep, thank you.
Thanks, Maxim. I think we have one question in the chat from Evgeny. So he asking about the backend integration. Did you mean something like integrating with Laravel Blade Vue files?
I meant more about integrating with your API endpoints. If it's complete solution like Laravel, I think in theory we can scan what API routes do you have here, and we can handle events, for example, on click event, and call this API endpoint from the dev tools. So you will have a list of available APIs endpoints. It depends.
Okay, get it. Summarizing all of that, are we assuming that Vuestic Compiler, together with new DevTools, turning the framework in the next level and something bigger than just UI framework, right?
Yes, I also see another one question about clean theme.
Yeah, we have a question from Maxim. Is possible to set only for few components? For example, to use styled buttons but clean calendar.
Yes, I think the main point is to have this not globally, but you can override some of the components if you don't really like how they look. But usually, in my experience, I have some of the components from Vuestic looking like designer want them to look, but some of the components looking completely differently. So having a clean theme for separate component makes sense, and I think that's will be our target.
Okay, cool. Yeah, we have one more question. What is the benefits of DevTools since we can reach the same with HMR? What directly changed the UI on your browser?
Okay, yeah, I think sometimes writing code even can be faster than working with visual tool, but I think this DevTools is meant for more for the backend guys who don't really like writing front end, who don't really like to go through the documentation, learn all of the props available and how to use them. With visual tool, you can see this all on your screen. You can see the types, because if it's a color, you can see list of colors with preview, little preview. And instead of keeping it all in your head, if it's not front-end guy in your team, he's still able to manage your application.
Thank you. Thanks for comments, guys, in the chat. I think we have no more questions at the moment, so we can go further to our next speaker. Thank you, Maxim, again.
Pavel, I put the link for our repository to the chat. It's open source, forever free. We don't have any paid option. You can do everything you want. And if you like it, you can give us a star.
Yeah, thank you for that, guys. So move on. Let's go to the next speaker, Dima. Dima is our senior developer with a deep background in building e-commerce platforms, and he also a Vuestic UI contributor. So today he will share his insights on rethinking solid principles in JavaScript. Microphone to you, Dima.
Yeah, hello. Can you hear me all? And can you see my screen? Let me know. Nobody's answering.
Yes.
Oh, okay.
Yeah.
Thank you. So yeah, my name is Dima, and I'm a software engineer, and I'd like to share with you today some of my insights regarding the solid principles in relation to JavaScript and frontend. Okay, the solid principles collection was introduced quite a long time ago, like back in 2000, and aimed to develop basic concepts for writing software products that would be resistant for constant changes in requirements and at the same time reliable and easily supported. And the original work mostly concerned the object-oriented approach, and accordingly, specific application examples were also mostly developed for those languages and technologies where OOP occupies a dominant position. So more than 20 years have passed since then, and but there are not that many materials on this topic in relation to JavaScript and front-end development particularly, at least when we compare it to similar publications in traditional OOP languages. So I do not pretend I will fill this gap today, but I'll try to give a couple of examples in real applications that I have encountered myself. So a quick introduction to the principles for those who probably doesn't know it. So SOLID is an acronym, and its letters stand for like single responsibility principle, open closed principle, list of substitution principle, interface segregation, and dependency inversion. So today, as we have quite limited time frame, I will touch upon mainly on two or three principles, and probably in the next time I will touch upon the rest. So we'll start with single responsibility. As the name suggests, every software entity should have only one responsibility. So if we'll try to apply the principle to structuring our components, the output may be like this. All components are broken down into several types: layouts, pages, composing components, and atomic components. Layouts serve as the main structuring components of the page, and they are reused in different views that share the same layout. Pages, like each row on the site has its own view. A view is responsible for retrieving the application context and resources from modules that are directly consumed by the view itself. And it's also responsible for assembling components needed to present the content of the page. And one note here that views do not orchestrate or distribute state behavior or communication between child components. Instead, we use different types of delegations. Only presentation props are allowed, like Boolean values or style shaping values, leaving application states and actions to be resolved by business entities in the component that directly consumes them. So the second one, or the next one, is composing components. They usually bundle a feature by including some other nested composing components or just atomic ones. And the same principles of single responsibility, delegation, and scope apply to them. And the last one is atomic components. These are just building blocks for our application. They should be like as dumb as possible. So let's go to some examples. Like all of the above may seem quite obvious, but it's not that hard actually to violate this principle. Let's say you have a composable, like called, for instance, use category, and this composable is supposed to pull all the products for the product list page. And you can see on the screen some possible code for this composable. And here you can see the violation of the principle of single responsibility, because when we start to get products, our composable knows something about loader, and it starts it, and it knows something about error messages, how to show them, and it knows something from like Vue perspective. And apart from the composable itself, which suddenly knows too much, your page knows too much as well. Although the only purpose of this page to arrange elements on the view, and that should be it for the page. So how can we approach this? Like, first of all, we can do some refactoring for our composable, and we can use like the following structure. As you can see here, this structure reduces functionality for this composable to just one main purpose: abstracting away an API layer responsible for products fetching and updating, etc. And that's it basically for the composable. Next, we're just saying to some dedicated components to do their job without polluting our page state. You can see here some like Boolean properties, like show error messages or show recommendations. Those usually should come from something like feature flags or other type of configuration. It doesn't really matter. And we also can use on the page some style shaping properties, because it's the main purpose of the page. Apart from this, we're creating different communication between different components if needed, with separate abstraction layers. It can be anything like event bus, or provide inject communication, or other techniques to delegate the work. So, but now with this approach, we can move our components to different places without bothering if it breaks anything, because all necessary logic is contained by the component itself. So we'll go down to the next principle. It's called open-closed principle, which means like software entities should be open for extension, but closed for modification. And we can see one of the examples of this approach. For instance, we have a component and its primary goal to show, for instance, a user's full name, and we don't expect this logic will change anytime soon. And even if something will change in our markup for this component, we'd rather not to rewrite the script responsible for this logic, even if we'll use different integration, like you can see here. And what we do, we're abstracting away the API layer so that we'll use the same code, just replacing the utilities like use user and use getters. You can see here how it works. Basically, to get the user full name, we just use separate layer of abstraction and get the full name from there. So when we need to switch our integration, we just need to use or probably write new ones for our abstraction layer, like use user or use getters. Okay. We'll get down to the next one. Like the next principle of SOLID is it's a list of substitution principle. The central idea of this principle is designed by contract. To illustrate the idea, I'll give a quick introduction of my last project I've been working on until now. Let's say there's a company that owns a number of brands of apparel, footwear, and accessories, and each brand has its own specifics, both in terms of technical implementation of the provided services and in terms of the overall design. All brands have a common code base, so it is very important to get rid of unnecessary pieces from other brands when assembling an application for a specific brand. If we simplify things a bit, the structure of the project would look like this. You can see like brand folders here, brands folders here, and like I named it like Epicmax and WL, which stands for like white label. And also we have here a core folder, and you can see that all those folders have the same structure, and the core functionality, what resides in the core folder, is everything that should work out of the box. And basically, it contains all the contracts for our application to work correctly. So let's look at the next slide. And for instance, you can see here that, for instance, we have a product cards component, which is responsible for rendering like the names such as the list of product cards. And at the same time, a product card for each brand should look differently. We don't want to rewrite any of our course code to approach the problem. We just want to substitute the correct brand's card at the build time, for instance. And here we see how it would look like from the code perspective. For the sake of simplicity, here we only require for product card to have a dedicated add to cart method. And in real application, of course, it can be a lot more complex. But the main idea for the substitutes is to follow the same contract. If you work in a big project, you can help other developers to follow the pattern by using something like generating scripts for the brand's components containing all the required bindings, or by creating an ESLint rules, making sure that the contract is being kept. And apart from making your code more resilient, such approach also gives you an opportunity to make sure that redundant parts are not going into your bundle and properly tree shaken. Yes, so, and that would be probably it for today. Thank you.
Thank you, Dima. We have some comments in the chat from Alexander. Could you tell what's wrong with, for example, having get user data utility method in the composable, which calls some API endpoint, instead of duplicating this in every component? I mean, this is probably the main point of your speech in S methodology.
I wouldn't say that I was talking about this exactly. I'm probably not getting this question completely.
I think the question about why do we need to get rid of, for example, calls of other composables in the composables and move them to the components. If we have many of the components, we will have many places where we're doing the same, for example. I think that's the key point of the question.
Okay, so the main issue with having that get user data in the composable itself, that if something changes with our API or integration, we need to go back to our composable and rewrite it. And we can get rid of this just by separating this layer from the composable itself. Because if you have like simple structure for your composable, you can write it once and never get back to it, basically, because it will always work. So the reason is that it's better, sometimes it's better not to be that dry, like we say, to repeat some things, but we don't want to rewrite things that are already working and are tested, and yeah, that something that just works and tested shouldn't be rewritten without any good reason.
I think especially when we talking about some testing, if we will try to write some unit test, if we will have a lot of logic from other composables inside one composable and we want to test it, I think we can face with a situation where when we will need to mock everything related to these other composables, not related to what we wanted to test, right? And probably some other issues with that. Another question from the chat: isn't that the whole idea behind having composables?
Composables is just one of the mechanisms to abstract away things. So this is not the whole idea of having composables. I think the whole idea of having composables is to make it more explicit what we expose from composables, because if you remember, before composables we had mixins, and when we used mixins it wasn't that clear sometimes from where some method or property came. So yeah, anyway, for instance, when we are talking about open close principle or whatever else principle, it's all about abstractions. So composable is a mechanism, not a principle.
Thanks, Dima. I think you guys noticed that Dima left 2 other principles for the next time. Probably we'll have them as a separate topic in our next talks.
Yes, and I also plan to do some live coding next time, because I'm preparing like demo application for this purpose. So yeah, I have such plan.
Yeah, thank you, Dima. Thanks. And I think we have no more questions right now. Maybe we'll have some more at the end of our talks. I think we can move forward. Let me try to share my topic right now. Okay, give me 1 sec. Am I sharing the screen right now? I think I'm doing it probably a little bit wrong, right?
You're sharing the whole screen.
Let me try to fix that really quick. Okay, probably this is the proper way. Okay. Do you see it now?
Yes.
Yeah,
Yes.
Thank you, guys. Okay, as you already know, my name is Pavel. I'm also a Vue.js developer in Epicmax, working with a lot of projects, with a big e-commerce as well, and also building my own pet project based on the Vue.js. But today topic will be not related to Vuestic. It will be about understanding and solving some hydration errors in Vue.js itself. So in this topic, we will think about what is hydration itself, the importance of server-side rendering, how hydration works, why are hydration mismatches is a problem. We will figure out the common hydration errors, and also we'll talk about the best practices and what should we do to avoid such kind of errors. So moving on, what is hydration? First of all, let's go to the definition. Hydration refers us to a process when server-side rendered static HTML is converted to an interactive page by hydrating it with the Vue.js on the client side. So actually, there is 2 phases. We'll talk about them later. Why it calls hydration is just simple, like adding water to something dry to bring it to life. Vue.js also hydrates static HTML with the JavaScript and make your content dynamic and interactive. Of course, if you have such functionality in your project. So the key point there of this part is hydration occurs after the initial server-side rendering and allow user to interact with some components without waiting for the full client-side render. Moving on, the importance of server-side rendering, SSR, as you can call it. So what is SSR? SSR allows Vue.js components to be rendered on the server in the first phase, which then sends the pre-rendered HTML to the client. And this leads us to the faster initial page loads because we already have some static HTML there. and also for sure some SEO optimization, again, for the same reason. So how SSR works? First of all, we have server and client side, and server side generates some HTML from Vue components and send it back to the browser. The page is rendered immediately without waiting for some JavaScript execution. As you can see on this small schema, on the left side we have server side, which like going through your components, parsing them, building some static HTML files and sending them to the browser. And then under the hood, we have some hydration process, which add in reactivity system of Vue.js, and then we get fully rendered page. As an example, we can say about some e-commerce website where we have product listings, and they should be displayed to the customer as fast as possible, because this is the good UX experience there. And then Vue.js hydrates the page, and we get additional functionality like some beautiful animation functionality to add into the cart and stuff like that. Maybe some slideshows, I don't know, many of them. So how hydration works? As I said, first of all, we have server-side rendering. On the server side, we are generating, I believe I'm speaking about that third time in a row, we're generating static HTML from Vue components by executing Vue.js application on the server side using Node.js, or if you're using some Next.js framework, which is also used Node.js under the hood. So when the request is made, the server runs the Vue components, process any necessary data to the API request, and renders the components into HTML strings. These strings are then sent as a part of the response to the client when they are displayed as a static HTML. This HTML is later hydrated to make it all the content, all the functionality interactive. So now we come into the client side. Once the client receives the static HTML, Vue.js takes over and first creating the virtual DOM from the components tree. Vue.js compares the virtual DOM to what already rendered as HTML and checks for any disappearances. If the server-side HTML matches the virtual DOM, Vue.js attaches its reactivity system, such as event listeners, data binding, to existing DOM elements without any re-rendering. This process enables interactivity while maintaining performance benefits from the server-side rendering. So you need to keep in mind that we are rendering components, let's say, twice, once on the server and the second one in the client. So why are hydration mismatches is a problem? Actually, there is a lot of reasons why. If a mismatch occurs, the client script must discard the server output and rebuild the HTML from scratch. And this leads to several issues. First of all, we are wasting server efforts. We are doing the work that is not needed anymore because we'll do the same work again on the client. So not that good, right? Another one is flash or of incorrect UI. Some customers may face some issues with content shifting, some blinking, which is not really good if you want to build a good UX application. For sure, we can face with some SEO and core web vitals issues there, because some crawlers may not see the content you are getting from the server side. So yeah, depending on the extent of mismatched, important metrics like load time will suffer as well. Going forward, we'll have performance degradation. That's also because we are wasting our work we done in the server. So again, it's the same. Our client will be slower, resources usage will be higher, especially when we dealing with some complex big pages or some dynamic content there. Next problem is increased network usage. If clients need to fetch additional data or assets or anything else, that can lead to increased bandwidth usage, slowing down page performance for the client. Potential for JavaScript errors, especially if you're using some third-party libraries there, that relies on some conditions in your components, you potentially can get a lot of errors, and that would be really painful to debug them and to understand what's actually wrong. Inconsistent state management and increased CPU usage on the client. That is also common things that you may face with as a result of content mismatch. And of course, last but not least, potential accessibility issues, because in a modern one, we should take care of how we are building our website to people with some accessibility issues. So yeah, we should take care of this as well. Moving forward, let's go to some common hydration errors we have. And in the meantime, let me hydrate myself a little bit. Okay, yeah. Common hydration errors. First of all, we're talking about mismatched HTML content. The server generates HTML doesn't match that Vue expects on the client, causing the mismatch. I have 2 examples for you guys there. First of all, the server rendered timestamp different than the client version. You know, as I had told you before, we are rendering our component twice, once on the server and then sending HTML back to the client and then doing the same on the client. So if we rely on some time, or we generating some values based on the time, those timestamps will be different between server and client, and we will face with this problem, mismatched HTML content. So example number 2, using VIF directive on the root element in your component. You can, as a best practice, you can solve that by not using VIF. Probably you should prefer vshow for that, because vshow is not completely hiding your element from the component. Okay, going forward, timing issues with JavaScript. That's possibly the same thing I talked about in example 1, but let's discuss it a bit more. So client side on the JavaScript may execute before Vue fully hydrates the document object model, causing unexpected behavior. As an example, elements relied on the window size can cause issues because they have differently on the server and the end client. And on the server, we even don't have window objects. So we already facing some problem there. We have something on the client, but we don't have it on the server. Going forward, another common hydration error is state synchronization problem. If the server and client states are not synced properly, the component may not hydrate correctly. That's actually quite obvious. As an example, async requests and data fetched differently on the server and client. This is also will cause some mismatch of the content. Okay, let's go to the next section, best practices. So first of all, you should avoid rendering random or some time-sensitive data on the server side. I mean, not the server side, but on both sides. For instance, avoid generating timestamps or random numbers during SSR. Instead, use some static data on the server and then update it in the client after hydration if needed. You can use some lifecycle hooks in Vue for that. As an example, if you need to display the current data or time, render some fixed value on the server, for example, the page load time, and then update it in client in some lifecycle hook like unmounted or any other you want to. Another point is ensure data is fetched both on server and client. When using SSR, prefetch the necessary data on the server side before rendering the component so that the rendered HTML has all the required content. Then, when the component is hydrated already on the client, use lifecycle hooks like unmounted to fetch or update some client-specific data. So actually, it's close to the previous point. As an example, for API that calls and fetches user profile, ensure the data profile is fetched and rendered on the server. On the client, the same API call can be used just to update this profile after hydration with some another parts of data if you need to. And the last one, CSS media queries instead of JavaScript breakpoints in SSR, especially in some of the UI framework. We have breakpoint services, which is relying on the window, which is not really good when we trying to avoid some content mismatch errors during SSR. So allow the layout to adapt based on the screen size without relying to JavaScript. The browser handles these queries during rendering, ensuring consistency between server-rendered HTML and the client layout. Implementation even simpler if you are using some CSS frameworks like Una CSS or Tailwind, because we have utility classes, including media queries there. So yeah, I think that's pretty much it. There is some key takeaways, on the screen. You can read about what we just went through. Again, we discussed what kind of common causes of hydration errors we have, and what best practices we can use to avoid using them. I think, yeah, that's pretty much it. And we go into the questions and probably answers section, sorry. I see a lot of comments in the chat. Let me try to determine where is the questions and where is not. Many jokes. Thank you guys for that. Question answered. If you're using CDN like Netlify Akamai for caching, this could cause mismatch too when the data wasn't parsed there in time. Yeah, that's totally right. Do not use breakpoints, and kill in the face there in the chat. So yeah, if we have no more questions, I think we are going to the end of our talks. We're already right in time. So I wish you to say thank you all guys for participating in this in our Vue.js talks. We definitely will make a few more in the future. So let's stay in touch and see you guys on the next meetings.
Oh, we have one question. Maybe I can, I don't know. We have someone. No, maybe it was just a mistake. Okay, no problem. We have a question about Vuestic. Yes, will Vuestic always open source? Yes, we don't have any plans for developing something paid around Vuestic for now. And for our framework and idea, you can use it for everything.
You can always join our Discord channel and ask any questions about Vuestic there. Yeah, reaction time is quite fast there.
Yeah, we can wait maybe 1 or 2 minutes if you have any questions about Vuestic, about our topics today. We can manage it. And I hope we can do same tech talk. I have a dream about every month, but I don't know. Let's see how it goes. And yeah, maybe if we don't have every day, yeah, okay.
So Maxim said that he decided to make a breaking change and destroy people's principles, people projects, removing breakpoints in SSR. Yeah, quite good thing.
And a question from Vasil, about topic for upcoming meetings. I have all your emails, and all people who mark this checkbox for showing me interest in being speaker, I will contact you after maybe next week. and ask for topic you're interested.
Yeah, I think we also have a question from Bulat. Where can I read about solid principles with Vue? Is there an article online? I'm pretty sure there should be some articles online. I don't think we already created our own, but after the next Vue talks, where Dima will present his second part of the principles, we'll create this article.
Yeah, I'm working on it.
And I will collect all information and send you all a mail maybe this week, and with video recording too. And maybe Dima can collect some links and articles if you have about Solid. If you can share something.
As I was saying, there are not that many articles regarding JavaScript and Vue in
You need to write
particular,
it.
or front-end. Yes, so that was the purpose for me, just to sit and make this material available.
Yeah, cool. So stay in touch and you'll get this article as fast as we will create it. So if no more questions, I would like to close the meeting. So thank you. Thanks, everyone. Thanks to our great speakers today. And see you guys on the next talks. Bye-bye.
Bye.
Right.